Welcome. So this is a set. What is a set? A set is an unordered collection. First point. Unordered collection of distinct elements. Unordered collection of distinct elements. So there are two keywords here. One is unordered and distinct. What is meant by unordered? What do I mean when I say unordered? For example, let's say if there is a set S1 and that set S1 is 1, 2, A, B, C, 3, 4, okay, or Z. This is one set S1. Let's say that in a programming language you implement a set. Then whenever the elements of the set S1 will be printed, it will not be the case that it will always be printed in this order. That 1 will be printed first, then 2 will be printed, then A will be printed, then B will be printed. It will not be the case. Yes, the elements 1, 2, A, B, C, 3, 4, Z, only these elements will be printed because these are the elements of the set. But the order of the elements is unsure of. Means it is not an ordered collection. This is one point. This is one point about being unordered. The next point is, let's say I have a set S2, which is 1, 2, A, B, D, C, E. Then this S2 is not a set. S2 is not a set because you have 2D here. So it is like saying it's a duplicate. Okay. So you don't have duplicates in a set. All the elements have to be distinct. So it is an unordered collection of distinct elements. This is what I mean. And let's look at the case study of employees of an MNC. Okay. So let's say in an MNC there is a project, and in a project there are many teams. A team of developers, team of testers, team of database administrators. Okay, there are other teams as well, but we are concerned. There are other teams as well, but in this example we have this set of 3 teams. Like S1 is a set of testers, S2 is a set of developers, and S3 is a set of database administrators. So who are the testers? Bhupender Yogi, Vinod, Kamlesh, Guddu. These are the testers. Amar, John, Sena, Komal, Kumar, Sanjana, they are developers. And Brenda, Narendra, Mahendra, Pallavi, Shilpi, they are database administrators. Now in every team is led by somebody. So S4 is a set of team leaders. So Guddu is leading the team tester. So Guddu is a tester. Guddu belongs to S1 and Guddu is the one who is the team lead of tester. Similarly, Amar leads the developers and Mahendra leads the database administrator team. And in every project there are managers. Managers are not part of any team, but they actually allot works to the team, and then the team lead is basically responsible to means they talk to team leaders only. Team lead is basically responsible to complete the tasks on a given due date. Anyways, so in a project S5 is a set that has the manager, and undertaker and stone cold are the manager. Let us say that. So these are the sets. These are the sets. Okay, tester. So each of the element in a tester are distinct. Each person is a different person. Okay, good. Now what is a universal set? Universal set is, what is a universal set? Universal set is set of all possible elements in the given context or scenario. Universal set is set of all possible elements in the given context or scenario. What does it mean? It means what is the context here? The context here is the employee of an MNC. Okay. So what does the universal set will be? Universal set will be set of all employees in that project. Okay. So this is a universal set in this context. Such that X is an employee. So a set that has all the employees in it, this is a universal set in this context, in this problem. So the content of the universal set depends upon the scenario, depends upon the context. In this context, we are talking about the employees of a given company. In some other context, for example, let's say we are dealing with a school system. There is a school. Okay, there is a school. In a school, there will be students, and there are many students who will pursue, let's say, PCM, physics, chemistry, math. There are some students who will pursue physics, chemistry, biology. Then there will be set where set of biology students, set of students who pursue biology, and set of students who pursue mathematics. So these will be two sets. But what would be the universal set in that context? Universal set is simply a set of students. So in this context, the universal set is set of an employee. Set of an employee. What is a subset of a set? What is a subset of a set? If every element present in B is also present in A, but not necessarily vice versa, then B is subset of A. Then B is a subset of A. Okay, what does it mean? It means, let's say that you have a set. Let us say that there is a set A. Okay. Let's say there is a set A which is 1, 2, 3. Okay, 1, 2, 3. There is a set A which is 1, 2, 3. Now there is a set B which is 1. Okay, let's say this is B1. There is another set B2 which is 2. Another set B3 which is 1 and 2. Another set B4 which is 1, 2 and 3. If you look at B1, the element in B1 is present in A. The element in B2 is present in A. The element in B3 is present in A. The element in B4 is present in A. So we say that B1, B2, B3, B4, they are subsets of A. So any set B is a subset of A if the elements of B is present in A, but not necessarily vice versa. For example, if you look at B1, A has element 2 and 3, but B1 does not have 2 and 3, but all the elements that is in B1 is in A. Now let us look at, for example, let us see this set of tester. S1 is a set of testers X such that X is a member of team tester. So S1 is a set of testers. What is S6? S6 is X such that X is a female tester, and S8 is X such that X is a male tester. As you can see, in a set tester is Bhupender Yogi, Vinod, Kamlesh, Guddu. Bhupender Yogi, Vinod, Kamlesh, Guddu. There are no female testers here. No female testers. No female testers. So this is the set S6. So S6 is a set with 0 element. Okay, or S6 is a set with no element. This is also called as null set. This is also called as null set or empty set. Null set or empty set. Okay. Now what is S8? S8 is X such that X is a male tester, and every tester is a male tester. So this S8 is nothing but S1 itself. S8 is nothing but S1 itself. Okay. So here in this example, S6 and S8 are a subset of S1, where S6 is a null set and S8 is the set itself. So these are the two trivial subsets. These are the two trivial subsets of any set. Given a set A, the null set and the set itself are the trivial subsets of that set. For example, this is the set A. This is the set A, which is 1, 2 and 3. Okay, then phi is one subset and A itself. Phi and A, these are trivial subsets of A. Trivial subsets of A. For any set A, there is two types of subsets. One is trivial subset. which is phi and the set A itself, and the other is called the proper subset. Proper subset. What is proper subset? Okay, when you say that B is a subset of A, this is how we represent. This is the representation of subset. This is what is subset is. Okay, and what is proper subset? Any subset which is not trivial. Any subset which is not trivial. Any subset which is not trivial. Okay, and this is represented as B proper subset of A. So what do you mean by B proper subset of A? It means that all elements of B is there in A, but there is at least one element. There is at least one element in A which is not in B. Then you will say that B is a subset of A. B is a proper subset of A. Like in this example, A was a set. A has 1, 2, 3. B1, B2, B3. Okay, B1, B2, B3. Like in this example. Okay, in this example, B1, B2, B3. They are proper subsets. And B4 is not proper subset. So B1, B2, B3 is proper subset, and B4 is one of the trivial subset, which is the set itself. Okay. Look at another set, S7. S7. X such that X is a female developer. That is Komal and Sanjana. So if you look at the set S2 has Komal and Sanjana. So S7 is a proper subset to S2. Okay, what is S9? S9 is X such that X is a male developer, which is Kumar, John Cena and Amar. So S7 is all S9. S9 is a proper subset to S2. Okay. Now look at this. What is a universal set? A universal set is set of all possible elements. So any other set is going to be a subset of universal set. So whether it is S1, S2, S3, S4, S5, S6, S8, S7, S9, all of these sets are subject to universal set. Because in universal set you have all the possible elements. In universal set you have all the possible elements in that context. So any other set that you are defining, like you are defining set S1 to be set of testers, or S2 to be set of developers. So any other set that you are going to define, the elements in it is going to be present in the universal set, because in universal set it's a broad definition. There is a broad definition, all definitions combined. Okay. Or you can think about it in this way, that there is a domain. Okay. From that domain only you are going to get members. Okay. And universal set is a set of that domain. So every other set is a subset of universal set. That is what is here. Okay. So this is a universal set. This represents. So whatever universal set. If you take any set, then any set is a subset of universal set. Or any set is an element of power set of universal set. What is power set? Given any set A, power set of set A is the set of all the subsets of set A. Okay, so given any set A, power set of set A is the set of all the subsets of set A. What does it mean? Like for example, okay, let's continue with 1 to 3. A is equal to 1 to 3 only. Phi is a subset of A. Okay, the subsets of one length, these are subset. Then 1 and 2, 2 and 3, 1 and 3, 1, 2, 3. So this is the power set of A. Power set of A. This is power set of A. This and this, they are trivial subset. They are trivial subset, and all of these, they are proper subset. They are proper subset. Okay. So how many subsets are there? Now what is the number of elements in a power set of A? In this case, it is equal to, as you can see, 1 plus 3 4 plus 3 7 plus 1 8. It is equal to 8. Okay. So now, if the number of elements in set A is n, then what is the number of elements? What is the number of elements in power set of A? Like for example, here n is equal to 3. The number of elements in power of set of A is equal to 8, which you can write as 2 to the power 3. Why I am saying it is 2 to the power 3? It's because the answer to this is 2 to the power n. And how it is the case, I am going to show you. So take any example. Let's say this is my set A. Okay, A1, A2, A3, so on, An. Okay. So for every element A1 or A2 or A3 or A4, so on, An, every element has two choices. So for any subset of A, in any subset of A, A1 can be present or A1 cannot be present, may not be present. Okay, for any subset of A, A1 may or may not be present. May or may not be present. So it has two choices. Okay, or you can say ways. Basically, this question that how many elements will be there in the power set of A, how many elements are there in power set of A, this question is very much like the question that in how many ways can you make a subset of A. You can say that this question is very much like this question is actually, you can rephrase it, that in how many ways you can have a subset of A. You can have a subset of A. Okay, in how many ways you can have a subset of A, which will give you the number of subsets. Every way will give you one subset. So, and these subsets are going to be the part of the power set. So this question that what is the number of elements in power set is actually how many ways you can have a subset. In a subset of a set A, you may have A1 in the in the subset, or you may not have A1 in the subset. Similarly, you may or may not be present. A2 may or may not be present. A3 may or may not be present. So for every such element, you are having two choices or two ways, either to have them in the subset, in your subset, or not have them in your subset. Okay, so and so on. For n, you may or may not be present. Two ways. Okay, for example, let us take one scenario, one subset in this way. I am saying that A1 is not present. Okay, A2 is present. A3 is not present. A4 is present, and so on. So let's say A and B is present. So this gives you one subset. Another subset, A1 is present, A2 is present. All of them are present. Then this gives you nothing but A itself. There's one way in which all of them is not present. Then this gives you 5. So anyways, so every possibility that you take, okay, every possibility that you take, that you include A1 or you may not include A1, how many different possibilities are there? So this is equal to nothing but you have to multiply all of them together. Just multiply them and you will get all such scenarios. And this is nothing but 2 into 2, so and so on, n times, which is equal to 2 to the power n. That's what it is here. If the number of elements in set A is n, what is the number of elements in power set of A? Is 2 to the power n. So that's what it is saying, that any set is a subset of universal set, or any set is an element of power set of set, universal set. Okay, so any set is an element of power set. What does it mean? It means that given a context or given any scenario, how many different sets can you define? Okay, for example, in this context of employees of an MNC, what is the total number of employees? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 employees in a universal set, and we have defined S1, S2, S3 in some way, that team of tester, team of developers, S4, S5, okay, S6, S7. So all of these sets that we have defined, how many such sets we can define given a context? That is going to be equal to 2 to the power 16. 2 to the power 16. Okay. So if the universal set, okay, if the universal set, let's say number of elements in universal set is n, then how many sets are possible? How many sets possible in this context? How many sets possible in this context? That is going to be 2 to the power n. Okay, and of course 2 to the power 16 different sets are possible, but of course that's not what happens. Means you either want to know what is a manager, what is a team lead. Means 2 to the power 16 sets are possible, but maybe many of them will be meaningless in a real scenario. But okay, anyways, that's it. Okay, set operations we'll see in the next video. We'll see set operations, Venn diagram, and we'll cover everything in the next video. Okay, we'll cover up to this in the next video.